lesson will focus on methods used to draw a sample from a population. We will be looking at the different sampling techniques that fall under our two types of sampling methods, namely non-probability and probability sampling. Probability samples are samples that are drawn according to the laws of chance, whereas non-probability samples are samples that are drawn based on the subjective judgment of the researcher. So what we mean is selection is not random. You will understand non-probability samples better when we look at examples of it. We're going to look at three types of probability samples: simple random sampling, systematic sampling, and stratified random sampling. We will also look at two types of non-probability samples: convenience sampling and quota sampling. Now, as we said before, probability samples are samples that are drawn according to the laws of chance. To understand this, think of a hat or a box that contains numbers or names, whatever it may be, and you are picking these numbers or names, so you're doing a lucky draw. Simple random sampling is sampling in which each sample of a given size that can be drawn will have the same chance of being drawn. To understand this, let us look back at the lucky draw. So if we think of a box that contains 50 names and we want to choose 10 names, so we want to choose 10 winners. Every single name in that box has an equally likely chance of being selected. That is, that every single name has a 1 in 50 chance of being picked. So every possible sample, because there are so many variations of 10 names that we could draw from this 50, what we're saying is that every possible sample, so every single variation, has the same chance of being selected. And that is what we mean, or what we would call, simple random sampling. To explain this further, let us assume that we have a population that contains 20 people, and we want to choose 6 people from this population. So let us assume that we use the lucky draw method and we chose our 6 people. As you can see, we had a population of 20 people, and now we have a sample of 6 people. Our sample is a subset of our population. In practice or in your tests, you're going to be tested on simple random sampling using something called a table of random numbers, or the random digits table. And we will look at examples where you are given a table of random numbers, or where you are referred to a line to work with the random digits table. For our first example, we're going to look at generating 6 winning numbers in a lotto draw. Suppose the first 6 random numbers in the table of random numbers are given as follows. And we want to use these random numbers to generate 6 winning numbers in a lotto draw, where there are 49 numbers from which the draw is made, and they are all 2 digits. Now, this is very important information. We need to know our range, and we've been given that our range is from 1 to 49, and that our numbers are all 2 digits. So our first step is we want to rewrite the random numbers in a string of 2-digit numbers. If we were told that they are made up of 3-digit numbers, we would rewrite this as 3-digit numbers. Then we want to discard any numbers that are greater than 49. Why 49 in specific? It's because we're told that our range is from 1 to 49. Next, we're going to choose 6 numbers working from either left to right or right to left. In your question, you'll generally be told which way to work. In this example, I'm going to do it both ways so you know how to do it. In this example, we want to choose 7 winners at random, and we're told that there were 52 entries in our lucky draw, and we've labeled each person with a respective number from 1 to 52, and again we can see that our numbers are given in 2 digits. And we want to use the random numbers from the table below to choose 7 winners. So step 1, we're going to go ahead and rewrite these random numbers as 2-digit numbers. Now, when you're doing this, especially when you're working with a lot of numbers, what you want to do is you want to keep in mind your end goal. So we want to choose 7 winners at random, and we want these 7 winners to be unique. So we want unique numbers. We don't want to give the same person 2 prizes. So when you're writing out your numbers, you want to think about all of this. And you want to go ahead and think, okay, 12, yeah, that's within my range. 65, that's not within my range. So already I have 1 possible winner. Then 16, that's a possible winner. 16 again, that's not a possible winner. So now I have 2 possible winners. What do I need? I need 5 more. And I'm going to keep going in this manner. So this will save me the trouble of having to rewrite this entire table. Instead, I can just focus on the number of unique winners that I need. So the next step is we're going to go ahead and we're going to remove anything that's not within our range. And I've skipped a step here. You can also go ahead and rewrite this, removing any duplicates. Because remember, we want unique numbers. I did it in one step, so I chose my winners, taking into account that I would not choose any repeated numbers. And you can see I have 12, 16, 46, 11, 51, 9, and 17. So those are the numbers that correspond with the 7 winners for our lucky draw. In this example, we're going to be actually using the random digit table. Now, random digit tables were actually how we drew random samples in the past. Now we have things like functions in Excel and encoding languages. In reality, you're actually not going to be creating random samples using these digit tables. However, for testing purposes, you're most likely not going to be given access to things like Excel. So to test your ability to generate a random sample, you're going to be required to use the random digits table, or you're going to be given a list of random digits as we'd used in the previous examples. Now in this example, we want to choose 5 students at random from the top 10 performing biology students to go on a field trip. Okay, and we're told that we should use line 124 from the random digits table. In previous examples, we worked with numbers. In order to use the random digit table, you need to assign numbers to these names. And generally, you will assign numbers starting from 1 going forth. In this example, I chose to start from 65. And the reason for this is because of the specific line in the random digits table that we're working with. If I were to start from 1, it would probably take me a really long time to find 5 people. So just for this example, I chose to start at 65. Okay, so we have our numbers assigned to our people. Now we need to go to line 124. From this point on, the process is exactly the same as what we've been doing. We're working with 2-digit numbers. Our range is from 65 to 74, and we want unique winners, okay? So obviously the same person can't take up 2 spots, so we want 5 unique numbers. So what we're going to do is we're going to go ahead and list our numbers as 2-digit numbers, and again we're going to keep in mind our end goal. Having done that, I realized that once I reached the end of line 124, I still would not have 5 possible winners. In this case, what you would do is you would move on to the next line and you would list all of those numbers, and you would keep going until you get the number of winners. Next, what you do is you would remove anything out of your range, and then you would remove any duplicates, and then you would choose your winners. Okay, so I skipped the previous 2 steps, and you can see 71, 74, 72, 67, and 68 are winners. And these numbers correspond with Grover, Rachel, Nico, Piper, and Annabeth. So these are the 5 students who will be going on the field trip. Now we're going to look at advantages and disadvantages of simple random sampling. As we saw, simple random sampling is relatively easy. All we did was implement a sequence of steps and we easily generated a random sample. But the key thing was that we were working with small population. If we were in fact working with a large population, this would be a disadvantage. Because can you imagine having 100,000 people in our population and wanting to choose 10,000 people? It seems extremely time consuming, and it just seems painful to try and use a random digits table to generate 10,000 people. Another disadvantage is that we actually need the entire population. And in statistics, we know that most of the time we're just working with samples because we either don't have access to the population due to budget constraints or because maybe it's not possible, and sometimes we don't even know what the entire population is. Next, we're going to look at systematic sampling. Systematic sampling is sampling in which data is being obtained by selecting every kth object, where k is approximately your population divided by your sample. To understand this, I want you to think of a milk factory. Let us assume that the factory owner approached us and he wanted to know if the machines were filling in the right quantity in each bottle. So what we could do in this case is we could go ahead and choose maybe every 5th bottle of the lineup. That would make up our sample, and we can go ahead and do an analysis on those bottles. As an example, let us assume that we want to choose 500 students from a university where there are 10,000 students enrolled. And we are told that we should calculate k because we want to use systematic sampling. So remember, k is approximately your population divided by your sample. And in this case, we're told that our population is 10,000 and our sample is 500. So from this point, it's very easy math. You're just going to take 10,000 divided by 500 and you get the number 20. So every 20th student will be selected off the enrollment sheet. In the next example, let us say that a city's telephone book lists 100,000 people, and our telephone book is our frame of study, so it's our population. And we want to know how large does our sample size need to be if systematic sampling were done on every 200th person. So we're saying that we chose every 200th person from the telephone book. Again, looking at our formula, it's just a simple subjective formula in this case, where our population is 100,000 and k is equal to 200, and we get the answer 500. So that is, the sample will need to be approximately 500 people. You can probably see where I'm going with this. Because we only have three variables, being k, your population, and your sample, there's only three types of questions that you can get on this section. Okay, so our final example is if every 11th item is systematically sampled and you've produced a sample of 75 items, approximately how large must the population be? We've been told that our sample is 75 and that k is 11, subject of the formula, and we can see that our population needs to be approximately 825 items. The final probability sampling that we're going to look at is stratified random sampling. And stratified random sampling is actually based off of simple random sampling. Now remember, in simple random sampling, we had a population and we chose 6 people, either using the random digits table or maybe drawing out of a hat. Whatever the case was, we chose it according to the laws of chance. Now there is a general problem with this. Let us say that in our population, we actually had groups. We had males and we had females. But when we drew our random sample, even though we did it according to the laws of chance, we ended up with a sample with 10 males and 1 female. So what this tells us is that it seems as if there are more males than females. However, we know from our population that this isn't true. This means that our sample is not adequately representing our population. A solution to this problem is stratified random sampling, where we divide our population into groups or strata according to some characteristic, and we sample each strata using simple random sampling. As an example, let us assume that we had a population that was divided into groups, where our groups were ages 20 to 29, 30 to 39, all the way to 60 to 69. Now that we have our population divided into groups, we're going to go ahead and use simple random sampling to sample each strata. Now, as you can see, we've chosen 2 people from each group. How we actually come up with the number 2, we're going to discuss in further examples. In the first example, we're investigating the expenditure pattern of consumers, where our consumers are divided into 3 groups: low income, medium income, and high income, where we're also given the percentage of the population that each group is contributing. And we're asked to calculate the number of consumers that will be chosen from each strata to make up a sample of 500 consumers. So first, our strata are low, medium, and high. And we are told that each strata contributes 40%, 45%, and 15% respectively. Our first step is we're going to go ahead and we're going to use that percentage and our sample that's given as 500 to calculate how much each strata will contribute in our sample. As we can see, the low income group contributes 200, and we got this by taking 40% of 500. The medium, 225. We got this by taking 45% of 500, and 15% of 500 for our high income group contributes 75 consumers. As a check step, you want to go ahead and add up 200, 225, and 75 to ensure that this is adding up to 500. In this example, we're investigating the liver function in lions, where our lions are divided into adult males, adult females, and cubs. In the table below, you can see that we're actually given a frequency this time. So we're told the count of how many adult males, females, and cubs contribute to our population. We're told to use a stratified sample of 120 lions, and we want to know how many lions should be represented by each stratum. In this case, we're given frequencies. So we're going to use the frequencies for each stratum to calculate the percentage that each stratum or each group is contributing to our population. As we can see, adult males contribute 20%, adult females contribute 32%, and cubs are contributing 48%. Just by looking at this, we can see that cubs is actually making up almost half our population. Now that we have our percentages, again, we're going to do exactly what we did in the previous example, and we're going to use the percentages and our sample size of 120 to determine how many lions are going to be represented by each stratum. Adult males are going to contribute 24, adult females are going to contribute 38.4, and because this is a decimal, we're going to use our regular rules of mathematics for rounding off. It's less than 0.5, so we're going to round down, and we're going to get 38 adult female lions. For cubs, we get 57.6. This is above 0.5, so we're going to round up to 58. Especially when you're rounding off, you want to make sure that you do that check step and you add up 24, 38, and 58 to ensure that you're getting a sample size of 120. You probably noticed that you could have done this in one step, and I'm going to show you how. When you're first starting off, I would recommend that you do each step so that you understand what you're doing. If you wanted to do this in one step, you would simply take your frequency divided by your total population, and you would equate it to x, or any variable, divided by 120. 120 is coming from our sample size, 200, 320, and 480 is coming from our table of frequencies, and 1000 is coming from our population. And all you would do here is you would cross multiply and solve for your variable, and you would get adult males being 24, adult females being 38, and cubs being 58. So at this point, you're probably noticing how you're going to be tested on stratified random sampling. All you're going to be asked is to determine the number for each stratum in your population that's going to be represented in your sample. Because once you have your number for each stratum, we're going to go ahead and use simple random sampling to obtain our sample. Now we move on to non-probability sampling. Non-probability sampling, again, is sampling in which data that is readily available is used, okay? So if we had to use data from the internet, or if we used quota sampling, which we're going to discuss next, or if we did convenience sampling. Now, convenience sampling is sampling which involves getting participants wherever you can find them. So wherever is convenient, it's in the name. A very easy example of convenience sampling is a shopping mall. So if we had an interviewer go to a shopping mall and approach people and survey them, this is an example of convenience sampling. Quota sampling is a method for selecting survey participants, and we're going to do this in a non-probabilistic way. So quota sampling is performed in 4 stages. The first stage is to decide which of the characteristics of the elements of the population to be sampled from are of importance. Let us assume that we were interested in gender and age. In specific, we were interested in males over 50. Okay? So our next step is we want to decide on the categories to be sampled from, where categories are determined by cross-classification according to the characteristics chosen at stage 1. So what we mean is we're going to work with gender, male, age over 50, and we're going to determine our categories. In our case, it would be males over 50. What if we had gender, female and male, and age over 50? Then we would have 2 categories. We would have females over 50 and males over 50. The third step is we want to decide on the overall number, so our quota, and the numbers sub-quota to be sampled from each of the specified categories. So let us say we wanted 4 people in our sample. That would mean that we would take 4 people from males over 50 because we only have 1 category. And finally, we're going to collect our information required until all our quotas are obtained. In this example, we have a company that is marketing a new product, and they want to know how potential customers will react to their product. And it is decided that they're interested in age and in gender. So the characteristics of importance are specified as age and gender. And we are told we're interested in under 20, 20 to 40, and over 40. And we're interested in males and females. So the first thing you want to do is you want to go ahead and list out all of these characteristics. So we have age and we have gender. So remember, step 1 was to determine the characteristics, and we've already been told what characteristics are of importance. Step 2 was to determine the categories. So using these characteristics, we're going to cross-classify and we're going to get our categories. And I'm going to show you how to do this. So first, we're going to get under 20 males. Then we're going to get 20 to 24 males and over 40 males. Next, under 20 females, 20 to 24 females, and over 40 females. We cross-classified age against gender and we came up with 6 possible categories. If we had more groups under age or gender, we would keep going until we get all our categories. So again, just to show you, it was under 20 males, under 20 females, 20 to 24 males, 20 to 24 females, over 40 males, and over 40 females. Now we can see that we have 6 categories and we need to determine the subquotas for our categories. In this table, we have our subquotas for each category. And this is just an example. There is no specific way for you to come up with this. This is for me just to show you how quota sampling works. And the last step is to get the required information until all our quotas are full. And a way that we could do this is using convenience sampling. So we could go to a shopping center and we could survey people until all the quotas are full. The previous example was more to show you how quota sampling works. This example is more along the lines of something that may come out in a test. So let us say that Cadbury wants to market a new type of chocolate and they want to know how potential customers might react. And it is decided that age, under 18, 18 to 40 and over 40, gender, males and females, race, black, white, colored, and Indian are the characteristics that will determine the sampling. And we're told quota sampling is to be used. The first question is, how many possible categories are there to be sampled from? Now there are 2 ways you can do this. The first way is to physically go ahead and cross-classify and list out all of the categories. However, if you're working with many characteristics of importance and each characteristic has many groups within it, I would recommend using this method, where you count the groups for each characteristic. For age, we have under 18, 18 to 40, and over 40, so that's 3. For gender, we have males and females, that's 2. And for race, we have black, white, colored, and Indian, so that's 4. So we have 3, 2, and 4, and if you had to multiply this, you would get 24 possible categories. The next question is, what are the advantages of quota sampling? So quota sampling is relatively cheap and it is a really convenient way to obtain a sample in a short space of time. The disadvantages of quota sampling is that it does not depend on the laws of chance. So we cannot guarantee that the sample that is being drawn is being representative of the population. Because what if the interviewer who was surveying people just happened to approach pretty girls? So what happens is that our sample would only have girls in it when maybe our population included both males and females. So this is an example of how a sample is not representative of our population. Another thing about the interviewers is that they can introduce bias into our study because interviewers are generally going to tend towards people who look easy to interview. And because of this, it makes it impossible to estimate the accuracy of quota sampling. This brings us to the end of the lesson. You've done a great job coming this far. If this video has helped you in any way, please like the video and subscribe down below if you haven't already.